Welcome back, everyone. Next for hyperbolas, we're going to actually take some of them and graph them, or put them in standard form and then graph them. One of the things I wanted you to notice is that in standard form, the denominator of the positive term is always going to be a squared, and the denominator of the negative term is always going to be b squared. So when we take a look at a hyperbola in standard form, we can automatically tell what those values are. So let's start with letter C here. Some things that I notice is the x term is positive, so I write a little note to myself, opens left, right. I notice that the center is at 0, 0. I notice that the value of a is equal to the square root of 16, the positive root of 16, which is 4. And I notice that b is equal to the positive root of 4, which is 2. And then finally, c squared is equal to a squared plus b squared, which is different than it is for an ellipse. So 16 plus 4 is 20, so c squared is equal to 20, or c is equal to the square root of 20. So let's go ahead and graph this. And if you remember from the previous video, what I said was that I will graph a rectangle first to establish where the ellipse is going to be in its dimensions and draw in those asymptotes, and then I'll graph it. So I start with the center. Center's at 0, 0. I know that it opens left, right. I'm going to go 4 in each unit, in each direction from the center. Left and right, 1, 2, 3, 4. So there's a point there. 1, 2, 3, 4. There's a point there. That establishes the width of my rectangle. I'm going to go up 2 units from the center and down 2 units from the center, and that establishes the height of my rectangle. So my rectangle, for reference only, is going to be like that. And I'm going to draw the asymptotes through here as references, like that and like that. And now I'm going to graph the hyperbola. I know it opens left and right, so like that and like that. And remember, asymptotes are lines that graph approaches, so make sure your hyperbola just keeps getting closer and doesn't curl away from those asymptotes. And then finally, the focal points are inside, kind of what I would consider inside the hyperbola, the curve of the hyperbola. So the square root of 20. So if you're doing all this stuff without a calculator, you're going to need to estimate the square root of 20. Well, here's how I do it. I think of 20 being between two perfect squares, 16 and 25. So the square root of 20 has to be somewhere between 4 and 5. So I know that my focal points are going to be about there and about there. And that's how we graph hyperbolas. Let's take a look at letter D. So as I look at this, I know that this one opens up, down, because the y term is positive. I know that the value of a is equal to 3. I know the value of b is equal to 5. I know the center is at 0, 0. And I know that a squared plus b squared is equal to c squared. So c squared is equal to 34, or c is equal to the square root of 34. So we locate the center like we did in the previous problem. We move up and down 3 units because I know this opens up, down. So those are the endpoints of my transverse axis. I move left and right 5 units, 1, 2, 3, 4, 5. Those are the endpoints of my conjugate axis, 1, 2, 3, 4, 5. And don't forget, A doesn't have to be bigger than B in these anymore. So those points establish my rectangle that I'm going to use to help me draw my hyperbola. Asymptotes, opposite corner to opposite corner. And remember, this one opens up down, so I start at the endpoints of the transverse axis and I make my hyperbola approach my asymptotes, and make sure you draw one in each direction, one up and one down. And then the last thing we're going to do is we're going to estimate the square root of 34. So again, 34 is in between two perfect squares. Let's see, what would those perfect squares be? 25 and 36. So I know the square root of 34 has to be somewhere between 5 and 6. So up that amount and down that amount from the center. So 1, 2, 3, 4, 5 focal points about right there. 1, 2, 3, 4, 5 focal points about right there between 5 and 6. Alright, so I'm going to work with you on a couple more of these, and then I'm going to have you do a couple on your own. Pause the video, do a couple on your own, and then check your answers. So what you'll notice with letter E is that the center is located at 3, -2. It is a left-right opening hyperbola because the x term is positive, so A is equal to 3, B is equal to 4, and remember c squared is equal to a squared plus b squared, so 9 plus 16 is 25, so C is equal to 5, a Pythagorean triple. So let's start by plotting the center, right 3, down 2. It opens left and right, so I'm going to go 3 units to the left and 3 units to the right. I'm going to go up 4 units and down 4 units. And I am going to draw in the diagonals of my rectangle. And remember, it opens left, right, so I'm going to start at the endpoints of the transverse axis and sketch in my hyperbola opening right, and then the other part opening left. And the last thing we're going to do is we're going to move from the center 5 units to the right. So that's 3, 4, 5, open circle there, 3, 4, 5, open circle there. That's our hyperbola. Okay, on this next one, you'll notice that our hyperbola is not in standard form. And to get it in standard form, we're going to divide each term by 64 because we need the constant on the right-hand side of the equation to be equal to 1. So we divide this by 64. And then we're also going to simplify that. So 4 and 64 reduce, and we get y plus 3 quantity squared. 4 goes into 64 16 times, minus x plus 1 quantity squared over 64 is equal to 1. So now we can figure out all the information we need to about this hyperbola. So its center is at, be careful about this, its center is at -1, -3. The a value underneath the y term is, the a squared value is 16, so a is 4. B is equal to 8. And a squared plus b squared is equal to c squared, so 64 plus 16 is 80, so C is equal to the square root of 80. So let's go ahead and plot this. And when I plot this, I'm going to go to the center, which is at -1, +3, right there. I know that this is an up-down opening parabola, so from there I'm going to go up 4, 1, 2, 3, 4. I'm going to go down 4, 1, 2, 3, 4. I'm going to go left 8 and right 8, so 1, 2, 3, 4, 5, 6, 7, 8. And right 8, 1, 2, 3, 4, 5, 6, 7, 8. I'm going to draw my rectangle in for reference. I'm going to draw the diagonals of my rectangle in. And I am going to now sketch my hyperbola. Looks like that, and like that, and like that. And I need to locate the focal points. So 80 is between two perfect squares. 9 squared is 81, 8 squared is 64. It's closer to 9, so it's between 8 and 9, so it's approximately 9. So from my center, I go up approximately 9 units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So the focal point's going to be there, and down 9 units from the center. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there we have it. So what I'd like you to do is pause the video right now and complete letter G and H. Put them into standard form because neither one is. Find the location of the center. Find A and B and C. Draw the reference rectangle. Draw in the asymptotes. Graph the hyperbola. And then hit play again and check your answer. Alright, so now that you're done with those problems, this is what they should look like in standard form, their centers, the values of A, B, and C, and what the graph should look like. You can pause it here to check your work. One last thing I wanted to talk about is now that you have drawn the graphs, it's very easy to figure out the slopes of the asymptotes instead of trying to remember if it's A divided by B or B divided by A. So if we take a look at the graph on the left-hand side, you can see that this dimension right here that I'm drawing in red is 3 units long, and this dimension here that I'm drawing in red is 5 units long. So the slopes of our asymptotes are going to be plus or minus 5/3. And similarly, over on the right-hand side, the horizontal dimension here that I'm highlighting in red is 4, and the vertical dimension is 2. So our slopes of our asymptotes are going to be 2/4 or 1/2 plus or minus 1/2. So what I'd like you to do now is do the first assignment from the hyperbolas homework before you move on to the next video.